Good day and welcome. Now, as executives, we base our capital allocations, our strategic pivots, and our risk assessments on data. We inherently trust the numbers. But today, in this explainer, we absolutely must confront a silent destroyer of corporate value, and that is the flawed sample. We're going to examine exactly why the very foundation of your most trusted analytical reports might actually be systematically misleading you. Let's kick things off with a rather painful business scenario. Just imagine your product team launches a new, heavily funded feature. A month later, they survey the users. The results come in, and the survey reports an 85% satisfaction rate. The team is celebrating, the PowerPoint decks are circulating, the executive board is thrilled. But they've completely missed a fatal flaw. You see, roughly half of the customers who tried the feature actually abandoned the product entirely within the first week. The survey, quite naturally, only reached the active users, the ones who stayed. The half who left in frustration, well, they took their dissatisfaction right out the door with them, remaining entirely invisible in the data. You haven't measured market success here. You've merely measured the survivors. So, our agenda today is a highly structured diagnostic. We'll be covering 1. The satisfaction illusion. 2. The strategic risks of biased samples. 3. Survivorship and response traps. 4. We'll dismantle the sample size fallacy. And finally, 5. The AI-augmented analytics advantage. All right, Section 1, the satisfaction illusion. Symptom of a deeper flaw. We really need to understand exactly why the product team in our opening scenario was so confidently incorrect. As our source material brilliantly points out, 85% of the survivors are satisfied, which is a real fact. It is just not the fact the team thought they were measuring. And honestly, the crucial point is this. There is a dangerous chasm between the population a business actually cares about, which is all the users who tried the feature, and the sample they actually measure, the users who stayed and actually bothered to answer a survey. That gap, that is precisely where expensive misallocations of capital occur. It's exactly where you might double down on a failing strategy simply because the data looked impeccable. Moving on to Section 2. Strategic risks of biased samples. Diagnosing the root cause. Let's dive into how this builds into a rigorous diagnosis of these really costly strategic blind spots. We call this root cause selection bias. Basically, this occurs when cases in your sample differ systematically from cases not in your sample in ways that directly affect what you were studying. Now, I urge you, do not view this as some minor academic error or a technical footnote for your data scientists. No, this is a severe strategic risk. When selection bias is present, the absolute most critical data, the data of the dissatisfied, the departed, the disengaged, is rendered entirely invisible to the C-suite. And this brilliantly illustrates the mechanics of that deception. Look at the far left. There we see the true population in all its messy complexity. In the middle, a proper random sample accurately reflects that structure. But notice the biased sample on the right. It forms this pristine, tight, beautiful cluster. It looks highly actionable, right? Yet it is entirely distorted. If your management team makes a multi-million euro decision based on that skewed cluster, well, they are optimizing for a reality that simply does not exist. Section 3. Survivorship and response traps. The hidden pitfalls. We now must examine the specific, everyday business data collection methods that actually harbor these invisible risks. Just think about how familiar these common business data traps actually are. Take survivorship bias. If you study only your best-in-class, top-tier customers to understand loyalty, you are exclusively analyzing survivors. You learn absolutely nothing about the customers who churned, whose departure might actually be the most critical threat to your revenue. Then we have response and non-response bias. This is where the people who actually fill out your surveys are systematically different from those who completely ignore them. And convenience sampling? Well, relying on highly engaged pilot participants yields conclusions only about highly engaged early adopters, definitely not your broader, perhaps much more skeptical market. I really want you to pause for a second and consider this staggering number, 8,800. This is the precise amount of missing voices from a standard 10,000-person survey that receives a pretty typical 12% response rate. Just look at this funnel of attrition. From 10,000 sent, we drop down to just 1,200 finished. The absolutely crucial point to grasp here is that the missing 88%, those 8,800 individuals, are not missing at random. They systematically differ in their engagement, their available time, and most importantly, their overall satisfaction. So when you present that survey to the board, you are not presenting the voice of the customer. You are presenting the voice of the willing 12%. Which brings us to Section 4, the sample size fallacy, debunking false cures. We really need to dismantle a very intuitive yet highly dangerous executive assumption, the belief that bigger data is inherently safer data. Often, when a representativeness problem is suspected, the knee-jerk instinct is simply, let's gather more data. But we have to starkly contrast a random sampling error with a biased sampling problem. You see, increasing your sample size only reduces random error. It does absolutely nothing to fix systematic bias. If your collection method is fundamentally flawed, scaling up a bias sample of 1,000 to a bias sample of 1,000,000 does not suddenly give you the truth. It simply gives you a much more confidently wrong answer. Furthermore, please do not let a margin of error lull you into a false sense of security. A margin of error only captures the random variation that comes from finite sample sizes. It completely ignores the massive systematic biases of who was excluded from the data in the very first place. I really must warn you, the margin of error is a floor on your uncertainty, not a ceiling. Your actual error could be magnitudes larger strictly due to selection bias. Finally, Section 5, AI-augmented analytics advantage, the prescription. Identifying the problem is only half the mandate of a senior leader. This final third of our explainer focuses on how executives can actually secure a competitive edge. We're talking about using artificial intelligence not merely as a calculator, but as a sophisticated reasoning partner to pressure test data validity. Here is the exact strategic framework leaders should use with AI to surface unexamined assumptions before making multi-million-euro decisions. Step 1. Describe the data source and, critically, the assembly method directly to your AI assistant. Step 2. Ask this strategic prompt. Who is likely to be missing from this dataset, and how might their absence change the conclusions? And step 3, the ultimate pressure test. Is the population this data is drawn from the identical population this decision applies to? The AI will rapidly surface those invisible gaps, identifying precisely which customer segments or operational realities have been completely filtered out by your methodology. As our source material so wisely states, this exercise turns a passive read into an active interrogation. It is not about distrusting your analysts, right? It's about elevating the absolute robustness of your strategy. A corporate culture that treats sampling questions as routine, constructive diagnostics rather than defensive gotchas makes infinitely better use of expensive analytical work. By leveraging AI to automate this rigorous critique, you are essentially building an organizational immune system against bad data. So, I leave you with this provocative challenge. Look at the key metrics you will be reviewing at your very next board meeting. If your most trusted data's conclusion is fundamentally wrong because of an invisible selection bias, what would that missing invisible data actually look like? And, using the AI diagnostics we discussed today, how quickly could you check? Do not optimize your strategy for a flawless yet entirely fictional subset of reality. Thank you for your precise attention.